Morning. How's everybody doing? This morning we're going to be doing a lesson on Chapter 10, Lesson 4, Multiplying Whole Numbers and Fractions. By the end of the lesson today, you will be able to find the product of whole numbers and fractions and be able to show that product in simplest form. But first, let's look at the difference between a couple of expressions. And no, I don't mean these expressions. All right. So first, your teacher has a video from this lovely man, Sal, on what multiplying fractions looks like. Mine is going to be a little bit different than that, so I wanted you to be able to see both types. All right, so first I wanted to show you the difference between these two expressions. This first expression is 1/3 of 3, while the second expression is 3 groups of 1/3. So those both look very different. So I just wanted to show you what that looks like. If I have 3 holes and I want 1/3 of it, I would take 3 holes. This bar represents 3 holes. And I have to split it into 3 equal groups, and then I only want one of them because I want 1/3 of it. So if I split my whole bar of 3 into 3 equal sized pieces, I know because if I divide 3 by 3 that each box is worth 1. So in this problem, 1/3 of 3 is equal to 1. Over here, this problem would look very different. So this shows 3 groups of 1/3. So I have 3 separate boxes, and I want to show 1/3 of each box. So in this, in this first box, I will show 1/3. There's 1/3, here's another 1/3, and here's another 1/3. So I have 3 groups of 1/3. Well, 1/3 plus 1/3 plus 1/3 is equal to 3/3, which would be equal to 1. It's the same as 1. So I wanted to show you what that looks like mathematically. If I did 3 groups of 1/3, on this side I have 3/3, which is the same as 1. But if you look at the relationship between these two sides of the expression, 3 times 1/3, how could I get, using the operation of multiplication, how could I get 3/3? And I just want you to look at that for a second. All right, let's move on to the next slide. This also shows 2 groups of 3/4. So in your textbook or on an SBAC, it might give you a diagram that looks somewhat like this, and they want you to be able to show or demonstrate your knowledge of fractions by showing 2 groups of 3/3. So if I was going to show 2 groups of 3/4 here, it would look something like this. And this is a very easy way to see that if I have 3/4 here, and I have 3/4 here, I would have 6/4 altogether. And then we have to worry about asking ourselves, is that improper or does it need to be reduced? But I want to leave that as 3/4 for right now. If I show this mathematically, 2 groups of 3/4 as an equation, it would look something like this. 2 groups of 3/4 is the same as 6/4. And if you look at that equation, I want you to think about the connection between these numbers and this result, and how could you come up with that? So if you notice, you might see that the 2 and the 3, there is a connection between 2 and 3 and 6, right? If I multiply 2 by 3, I would get 6. And then my 4 stays the same. And I want to show you why that is. So if I make 2 equal to a fraction, what can I make 2 equal to be a fraction? Well, if I put a 2 on the top, what would I use to make 2 equal to 2 what would I use as my denominator? Well, if I chose 2, that means it's equal to 1, so that won't work. But if I make it 2 over 1, that's equal to 2, remember, because a fraction is always actually a division problem. And my denominator is always the divisor, and my numerator is always the dividend. So I would say how many groups of 1 are in 2, and there are 2. So that's my answer. So anytime you have a whole number over the number 1, it's always equal to that whole number. So if I said 2 over 1, that's equal to 2. 3 over 1, that's equal to 3. 4 over 1, that's equal to 4. And I want you to recognize that because in this equation, 2 times 3/4, if my answer was 6/4, I can put a 1 over here, and notice I can do 2 times 3 is 6, and 1 times 4 is 4. Let's look at the next slide. In this problem, it says 4 groups of a half. So that would look, if I was going to draw a diagram to demonstrate that, I would have to draw 4 groups of a half. So I'd cut all these pieces into halves to 2 equal pieces, and then I just want to shade one of the 2 pieces, so 1/2. There's another 1/2, there's another 1/2, and another 1/2. So how many halves do I have in all? I have 4 halves. So this is actually equal to 4 halves. Now if I do it over here, this is taking half of 4. So this problem, although the result will be the same, it looks different. So if I'm taking half of 4, if this bar represents 4 and I only want to take half of it, I would split that right in 2, and then I have to ask myself, well, if I'm splitting 4 into 2 equal pieces, I'm essentially dividing what is going to be on each side. What is each side worth? Each side is worth 2. So mathematically, both of my answers are the same because I know that 4 halves is equal to 2. So I have, if I'm taking 1/2 of 4, I only want one of those halves. That's equal to 2. And up here I also have 2. So let's see what that looks like if I write it as an equation. If I write 4 times 1/2, and my answer is 4 halves, what do you recognize about this equation? Well, it looks like I can multiply 4 by my numerator 1 and get 4, and 2 by nothing and get 2, although my 2 would just stay the same. I'm not multiplying it by nothing. If I was multiplying by nothing, it would be 0. All right, let's look at another expression. So in this expression, if I know that 4 is the same as 4 over 1, because we said this is really a division problem, and there are 4 ones in 4 holes, so this is equal to 4, I can write 4 over 1 times 1 over 4. Sorry, 1 over 3. Oops. So I have, this is really becoming 4 over 1. So I have 4 over 1 times 1/3, and I can multiply straight across. I'm going to write it like this because later on, when we are reducing fractions, you'll see that this will come in handy. So for right now, I just want it all on the same numerator and denominator. So 4 times 1 is 4, and 1 times 3 is 3. And we know that 4 groups of 1/3 is going to be 4/3 just because of the pictures that we can draw. But we also know that we can write it as 4/3 like this, and then we just have to reduce it. Remember, whenever we have a fraction as our answer, we have to ask ourselves, is it improper or can it be reduced? So, is it improper? Yes, the numerator is larger than the denominator. And remember, we've said fractions are always division problems. So the denominator is always the divisor. I try to remember denominator, divisor, denominator, divisor. And the numerator is the dividend, or what is being split. So how many groups of 3 are in 4? We have 1. And then I'm multiplying it. 1 times 3 is 3. Subtract, I get 1. So my remainder is 1 over 3 because I need 3 holes to make 1 more hole. Here's a good example of this, because if I was going to draw a diagram and take 2/3 of 5, if this whole thing is 5 and I split this evenly into 3 parts, I don't know what this is going to be because it's not a whole number. It doesn't divide up evenly. Those numbers are not compatible. So I could use commutative property and flip-flop these guys and do 5 groups of 2/3, right? And I could figure this out. Here's one group of, here's 1, 2, 3, 4, 5. And then I want 2/3 in each group. So I could say, okay, here's 2/3, here's 2/3, here's 2/3, here's 2/3, here's 2/3, and there's 2/3. So really that's like repeated addition, right? 2/3 plus 2/3 plus 2/3 plus 2/3. So I really need to find out how many groups of 2 do I have. I have 1 group of 2, 1 group of 2, 1 group of 2, 1 group of 2. Oh, I have 5 groups of 2. So if I added these all up and did repeated addition, I would get 10. Or I could do 5 times 2 and get 10. Well, look at the connection between that and what we just did. So remember, we said that 5 is the same as 5 over 1 times 2/3. And I'm really doing the same thing, 5 times 2. So I'd write that on the numerator, 5 times 2 over 1 times 3, and I would have 10/3. And then I have to ask myself, remember those 2 very important questions, is it improper or can it be reduced? Sorry, that's a 3. It is improper because the numerator is larger than the denominator. So then I need to divide. So I could ask myself, how many groups of 3 are in 10? There are 3 groups of 3 in 10. So I would, 3 times 3 is 9. Subtract to get 1. So I have 1 as my remainder, and 3 is my denominator. So 3 and 1/3. Okay, here's what I'd like you to do. Try a couple of these on your own. So pause the video and try these on a piece of paper, and then come back and see if your answers are correct. I'm going to go fast because we're running out of time. So in my head, I know that 3 and 12 are compatible numbers. So I could think to myself, well, if I only want 1/3 of 12, I'd have to split 12 into 3 equal sections, and then I only want one of those. Or I could do it like this. 1/3, mathematically, it would look like this. I need to change my whole number into a fraction, and then I would do 12 times 1 is my numerator, and 3 times 1 is my denominator. I have 12/3, and then I ask myself, is it improper or can it be reduced? It definitely can, because we know our numerator is larger than our denominator, so we're going to divide. How many groups of 3 are in 12? There are 4, so our answer is an even number 4. Our next problem says, I have 1/4 of 20. So again, in my head, I might think this whole box represents 20, and I only want 1/4 of it, so I could split this into 4 equal pieces. What's in each box? And I only want one of them. There's 5 in each box, and I only want one of them, so I know it's 5. But I could also solve it mathematically, because our fractions are not always going to be compatible numbers or easy to work with. So you want to figure out how to solve these mathematically, so when the problems become more challenging, you know what steps to follow. So 1 times 20 over 4 times 1, and I have 20/4, which is the same as, remember, I asked myself, is it improper? Can it be reduced? It is improper because 20 is larger than 4, so I need to use division to find out what this is equal to, and I know that 5 groups of 4 are 20, so I can subtract, and I have nothing left over, so my answer would be 5. And I am out of time, so I hope that helps you. If you have any questions, please contact your teacher, and we are happy to help or walk you through this independently. Don't forget to watch Sal's video.